Guys, in this video, we'll understand the naive-Bayes theorem and how to solve a problem based on the naive-Bayes theorem. Here is the theorem. The first step is compute the prior probability for the target class. Then the second step is compute frequency matrix and likelihood probability for each of the feature. Third step is use Bayes theorem to calculate the probability of all the hypotheses. Fourth step is use maximum a posteriori hypothesis to classify the test object to the hypothesis with the highest probability. So let's move with the question. Assess a student's performance using the naive-Bayes algorithm with the dataset provided in the table. Predict whether the student gets a job offer or not in his final year of the course. Here is the training dataset. It has the features or the attributes like CGPA, interactiveness, practical knowledge, communication skills, and the last column will be the target class, that is job offer. The first step is to calculate the prior probability of the target class, that is job offer. So the job offer class has either yes or no. Then the number of instances of yes out of the 10 instances is 7, and then the number of instances for the no is 3 out of 7. That is the same thing you have to write here. Probability of job offer is equals to yes, that is 7 yes out of 10 instances, and then P of job offer is equals to no is 3 out of 10 instances, that is 3 no's out of 10 instances. Then the step 2 is to compute the frequency matrix and the likelihood probability for each of the feature. The first feature is CGPA. So the frequency matrix is here. That is CGPA has 3 classes: greater than or equal to 9, greater than or equal to 8, less than 8. Then the job offer is equals to yes for the class greater than or equal to 9 is 3. Let's see here in the table. Greater than or equal to 9, then job offer is equals to yes. Then greater than or equal to 9, job offer is equals to no. So not this one. Greater than or equal to 9, job offer is equals to yes. Greater than or equal to 9, job offer is equals to yes. So how many? 3 instances are yes. So number of instances yes for the class greater than or equal to 9 is 3. Similarly for the no was 1. Same you need to calculate for greater than or equal to 8. The number of instances that are yes for the job offer target class is 4, and 0 no's. Less than or equal to less than 8, job offer yes 0 instances, and then for the less than 8, job offer no is 2 instances. And you can add the total comes 7, that is out of the 10 instances 7 are yes, and then out of the 10 instances 3 are no. That is the same thing you have calculated in the frequency matrix of the prior probability of the target class. This is the frequency matrix of CGPA, and then we need to calculate the likelihood probability of CGPA. For the CGPA, the P of CGPA greater than or equal to 9 and job offer is equals to yes equals 3 of 7. That is 3 instances are yes for the CGPA greater than or equal to 9 out of the 7 yes instances. This is the meaning, exact meaning of this statement. That is, the 3 instances of CGPA greater than or equal to 9 are yes for the job offer out of the 7 yes instances. And similarly, 1 instance of CGPA greater than or equal to 9 where the job offer equal to no is no out of the 3 no instances. Same you need to write. For here the CGPA greater than or equal to 8, job offer yes is 4. So 4 out of 7 will be yes, and here 0 out of 3, then here 0 out of 7, then here 2 instances of less than 8 has job offer equal to no, so 2 out of 3. This is how you calculate the likelihood probability of CGPA. All this stuff is will explain the same thing I have told you, so you can write it in your own words rather than by hearting this sentences. And then the first feature was CGPA, that is done. Now the second feature is interactiveness. You need to do the same thing here. The interactiveness has 2 classes, either yes or no. Then the yes instances that has job offer is equals to yes is 5, and the yes class of the interactiveness has job offer equals to no is one instance. Similarly, the interactiveness class no, which has job offer is equals to yes, is two instances, which have job of offer equal to no is two instances. So adding to the total yes will be 7 and total no will be 3. This will remain same for all of the features or the attributes. This was the calculation of frequency matrix, and then you need to calculate the likelihood probability of the interactiveness attribute. Since the 5 instances were yes, so 5 out of 7, then here also 2 out of 7, the same value. From this table you just have to take this value and divide it out of the total number of yes and total number of no. You can see 5 divided by 7 here, and then here 2 divided by 7, 2 divided by 7 here, 1 divided by 3, and then 2 divided by 3. That is all you need to do. You need not calculate anything from the calculator, and you need not worry. Everything is in the training data set, and then you just have to take a proper look of the data set, and then you have to analyze the number of instances and all. Just write it clearly. The next feature is practical knowledge. Do the same thing, exact same thing. I won't repeat it again. Then calculate the frequency matrix of practical knowledge, calculate the likelihood probability for the practical knowledge, and the last feature is communication skills. Here also you need to calculate the frequency matrix and then the likelihood probability. Once you're done with calculating the frequency matrix and the likelihood probability for all of the features or the attributes given, the next thing or the next step in the Bayes algorithm is you have to calculate the probability of all the hypotheses using the Bayes theorem equation. The equation is here. So P of job offer is equals to yes for the test data. So wherever the job offer equals to yes, and we have to consider the test data. The test data will be given in the question itself. This is the formula. P of CGPA greater than whatever the attributes of the test data, you have to consider those. Then P of CGPA greater than or equal to 9, job offer is equals to yes. P of interactiveness is equals to yes, job offer is equals to yes. And P of practical knowledge is equals to average, that is given in the test instance. And then P of communication skill is equals to good, that is also given in the instances. Test data. Then at the end you have to add this also. You should not forget to add this. That is P of job offer is equals to yes, because you're calculating for job offer is equals to yes, and divided by P of test data. Here we can actually ignore the P of test data because it is common for all of the attributes. For all cases you're taking it, so you can just ignore it. Don't add that value when you're adding the values for this. You just have to add the values which you have calculated earlier or in all of these tables, and just put it here, calculate, you will get some value. This is for P of job offer is equals to yes for the given test data. Next, the same thing you have to do for job offer is equals to no for the test data. Same again, you have to calculate all the values. You have to put all the values in this formula and then calculate it. You will get some other formula, some other answer here, and then don't do anything here. Just write the thing, write the formula, put all the values, and then calculate. Now, the step 4 in the Bayes algorithm is use the maximum a posteriori hypothesis to classify the test object to the hypothesis with the highest probability. What you have to do here is you have to compare the job offer is equals to yes and job offer is equals to no answer, final answer. As we can see that the job offer is equals to yes answer, we have got the highest. This is the maximum out of both. So we can tell that since P of job offer is equals to yes or on test data has the highest probability value, the test data is classified as job offer is equals to yes. So that we can conclude that the given test data, the student will student will get the job offer, that is job offer is equals to yes for this given test data. This is the conclusion of the answer. Thank you.